Assalamu alaikum. In this video, we'll learn how to use service catalog in Kubernetes. The goal here is to provision resources in the cloud and connect them to the Kubernetes cluster. The typical use case is the database. We know that it's a bit difficult to manage databases in Kubernetes because they will live inside the container and the container might crash at any time. So it's hard to have a high SLA of 99.99% and to have high availability, to have managed disks, and to have backup plans and failover plans and so on. While it's actually easy to manage all of those aspects in a PaaS service hosted on the cloud, because the cloud provider will control and will manage the database server and the database instances for me. So he will ensure that I have a high SLA of 99.99%, I have high availability, failover and backup plans and so on. So it would be really good to have the best of both worlds. My app continues to run on a Kubernetes cluster and I can benefit from all the services for the scalability, and my database and my data will run on a PaaS service on the cloud. And here service catalog is the service that can activate this connection between Kubernetes and the PaaS services on the cloud. In this demo, we'll learn how to use service catalog, and through a demo we'll go to provision a SQL Azure instance in Kubernetes and Azure, and then connect it to the managed Kubernetes cluster hosted on Azure AKS. So let's get started. Here, first of all, I invite you to go to check the osba.sh website to learn more about the open service broker for Azure and to learn more about service catalog. This is the let's say the official website for them. And then here I have already created an article that details what we'll be doing in this demo today. So you might find more explanation in this article. The code source for this demo, along with the scripts and the commands that we'll be using, are also available on my GitHub account on this repo right here. So go to checkout. Let's first start the demo by installing service catalog in the cluster, because when we have a Kubernetes cluster, actually service catalog is not pre-installed by default. It's up to us to install it, to add it as, let's say, as an extension in Kubernetes. So here I have already provisioned a Kubernetes cluster on Azure, an AKS using the AKS service, and I'll be using this instance in order to continue with this demo. So here, first of all, we need to install service catalog, and later we need to also install the Open Service Broker API. Those two components works together. Actually, when we ask service catalog to provision a PaaS service or a PaaS instance, service catalog will go to talk to the Open Service Broker API. Service Broker API, it have an implementation for each cloud provider. It have an implementation for Azure, which we'll be using today, which is called Open Service Broker for Azure, and it have also an implementation for GCP, AWS, and other cloud providers. So let's start by installing the service catalog. We have multiple options to do that. The easiest one is to use helm charts. So for that, I need to have helm installed on my cluster, and to make sure I have already installed it, I'll run the command helm init. And here, of course, I'm connected to my Kubernetes cluster, okay? And here it tells me that Tiller, which is the server part of Helm, is already installed on my cluster. So now I'll go to add the Helm repository for Azure that contains the service catalog. So to do that, here I'll go to use the command helm repo add. this will help me to add another repo, and I'll call this one svc-cat. And then I need to paste the URL from where to fetch the helm repository. Type enter, and here it tells me that the service catalog helm chart was now added to my list of repositories. Now I'll go to install the service catalog. So I'll use the command helm install. Then I'll use the repo that I have already checked in, svc-cat. Then the name of the helm chart that I want to install is here, call it catalog. Okay, so I install the service catalog from here, and then I want to add some other details, like here the name. So I'll call it a catalog. Then I'll go to install it inside a Kubernetes namespace, call it catalog. And here I'll set some environment variables, so I'll change those variables to disable airbag, and I want to enable persistence and health check disabled, and so on. Okay, so here I have airbag disabled, but for your production environments you should have airbag enabled as a security feature. Let's run this command, and in a few seconds we should see that Kubernetes will provision different resources for us right here. So we can see here we have installed actually some pods, some secret services, service account, and so on. And it have also actually created an API service called service catalog. So we can check that if we go here, kubectl get API service. You can see here the list of the API services, and one of them is my service catalog. So now I have the service catalog installed in my Kubernetes cluster using Helm chart. Let's go now to install the second part, which is the OSBA, the Open Service Broker for Azure. To do that, I'll also use Helm charts. And for this reason, I need to add another repository for my Helm charts. So to install the Open Service Broker for Azure using the Helm charts, first I need to add the repo for its Helm chart, and that's I can do that through using Helm repo add. I'll give it a name, let's say Azure, and then I'll paste the URL from where to fetch that new repository. Now it's added to my list of local repositories, and now I can use this Helm chart to deploy the OSBA into Kubernetes. But actually, to do that, we need to create a connection between Open Service Broker for Azure and Azure itself, because Open Service Broker for Azure is the API that will connect into Microsoft Azure and ask it to provision resources. So it needs to have the privileges or the right access to do those kind of operations. To give it this access right, we need to create the service principal in Azure. And to do that, here I have already connected to my Azure account using the AZ account. So I have typed already AZ login, and I'm connected to my account. And now I want to create a service principal using the command line. So the way to do that is using the command line AZ AD for Active Directory, and then I would say SP create for airbag. I type this command, and now this will connect to my Microsoft Azure, ask it to create the service principal, and then it will get a response with the service principal with all the credentials. And the service principal here is what gives access to API, to any third-party API, to provision or to manage resources in Microsoft Azure. After a few seconds, we can see here my credentials for my service principal. So I have here the application ID, the display name, the name, password, and the tenant ID. Along, I have also the subscription ID for my Azure subscription. Now we can use those credentials to provision OSBA. So to do that, I'll go to again use the command helm install. I'll install from the Azure repo, and here I'll go to install the Open Service Broker for Azure. So I'll paste this commands right here and here. So we are specifying the name Open Service Broker Azure. I'll call it OSBA, and I'll install it in a Kubernetes namespace, call it also OSBA, and I'll set the subscription ID. Okay, those are arguments that will be taken from the Azure, from the Helm chart actually. So the subscription ID, here I have put it in an environment variable called Azure subscription ID, and that's what is written right here actually. Then the tenant ID, I have done the same, and the value is the one written right here, the tenant. The Azure client ID is your app ID actually, is the value right here, and then we have the Azure client secret, and that's the password actually. Cool. Now I'm ready to run this example. This will take a few seconds, and then we can see the different resources deployed by the Open Service Broker API for Azure. So we can see here have created persistent volume, created a pod, secret, service, some cluster, service broker, deployment, and so on. And now to make sure it have created successfully those resources, I'll go to use kubectl get cluster service brokers, okay, and then I'll get the status. Here it tells me error fetching catalog. This actually will take a few minutes before it can provision this into the running status. So let's wait for it. While it's still provisioning, let's go to talk to something else. So here that we have already deployed the service catalog, we can interact with the service catalog using the kubectl command. But the development team for the service catalog have created another CLI tool called svcat, which have more features available to interact with the service catalog. To install this command line, we need to go actually to the website, to a dedicated website to do that. And that's available on this link, svc-cat.io. From here, you find what you can do with the CLI tool and how you can install it. Here we have the link for the install. So I have already installed it in my machine. And now if I go to explore what are the different commands available with svc-cat, so I'll go to clear this, and then I go to svcat --help, and I find we have actually different commands we can use. So we have commands for provisioning resources, for deleting resources, for binding, unbinding, installing, listing the available resources in the marketplace, because service catalog before or actually it can create those kind of resources, and so for that it have a marketplace that defines all of those resources. Let me take you here to the website for OSBA. So from here, for the case of Azure, for example, I have mentioned only the database services, but OSBA for Azure, we can use it actually to provision Azure SQL databases for SQL Server, or for Postgres, or also for MySQL. We can also use it to provision Cosmos DB instances and Redis cache. Note that those for today are still in preview, and we have some other experimental services for provisioning Azure Key Vault, Azure Event Hubs, Azure Service Bus, and Azure Storage. For the case of AWS and GCP, they have also their own list of the services you can create. And of course, the database is one of those available resources to provision or to manage from the service catalog. Let's go back and let's check if the cluster service broker was created. And now we can see it's ready to be used from here. So here we have used kubectl get cluster service brokers. So I'll go to clear this, and then I'll use the svcat get brokers. And here we get our OSBA broker already installed. We can also use another useful command, which is svcat marketplace. The marketplace will give me all the services that I can provision using the service catalog. So here we have already Azure SQL 12.0. This is what we'll be using in this demo today, but we have other services for the Azure Storage Blob Container, Azure Storage, Postgres, another Postgres with different plans and different services available. We have Cosmos DB and others for Redis cache and so on. Now that we have deployed service catalog with the open service broker for Azure, now we can start provisioning resources in Microsoft Azure using the service catalog. So let's do that. Here we'll be using the Kubernetes manifest files, and we have here another type available for us, which is the instance, the instance. So we'll use that in order to provision resources. Let's take a look at a file, the SQL instance right here. So you can get it from my GitHub repo, of course. Let's take a look at this file. So here, first of all, it will have a type service instance, okay? And here it have a name, and I want to install it into a Kubernetes namespace, call it OSBA. And then we have what is important here is the cluster service class external name. This is the name of the service that we want to use that we saw earlier from the svcat marketplace, Azure SQL 12.0. Then the plan we want to use here, Azure SQL databases have different plans. We have the basic, standard, premium, and so on. Here I want to use the basic plan. My Azure SQL database, I want it to be hosted on an Azure data center that is available on East US. And I want the name of my resource group in Azure to be called osba.-rg. I can also apply some configuration for my database to access the database instance. So here I can I specify the range of the IP addresses that I can access my database. Here I have allowed all. I have created a policy or a firewall rule to allow all connection of any IP address to my database. Great. Now we are ready to deploy this instance and see what will happen. So to do that, here let's make sure I'm inside the repo where I have the SQL instance YAML. Then I'll deploy it using the command kubectl apply. I can also deploy it through the command svcat deploy, okay? But here I'll be using kubectl create -f, and the name of the file is SQL instance .yaml. Hit enter, and now Kubernetes have received this request to the service catalog, and the service catalog have talked to the open service broker for Azure, and that one started provisioning the resource in Microsoft Azure. So now this means that if I go to my Microsoft Azure account, I should be able to see that there is a new resource group that have been created. So let's go here to the list of my resource groups. And they can actually see that here, yes, we have a new resource group created, osba.-rg, and note the location of that resource group, that is East US. For now, inside this resource group, I don't have yet any database or any instance created, but in a few seconds, if you go to refresh, we'll be able to see those will appear later. This will take a few minutes, so let's wait for it. Now we can see the SQL server created, and let's go continue refreshing, and later we'll see the database that will be added. And now we see our database was created along with the SQL Server instance. Great. Cool. Now I can go back to the command line and check that using the svcat get instances from the namespace OSBA. And from here, I can see my SQL instance already created, and it's ready to be used. Great, so now I can use this database with SQL Server to connect my application into it. But what should I do now? Should I go to, because to connect, I need the information about the credentials for the connection string. I need the database password, the login, the username, and the host URL. So what I can do here is that maybe I can go to this database file, and from there I can go to I can go actually to the properties and get the information about the connection strings right here. So I can then copy this connection string and paste it into my application. But this means I will go to share this connection string, which is supposed to be managed as secret value. Now I need to send it through Slack or email or whatever, or write it on a post-it, but that's not the secure way to do it. And here, fortunately for us, Service Catalog have implemented a solution for this problem. So what we can do here is to bind those information to the Kubernetes cluster. We can share actually this connection string to the Kubernetes cluster directly. It's Service Catalog who will do that. So no human intervention in this process. We can do this through using another kind of service available with Service Catalog, which is the service binding. So here, Service Catalog will take those credentials from Azure and it will make them available on the Kubernetes cluster. Actually, it will create a secret object and it will store those credentials onto that secret file so that we can use it later from our applications. Let's see how that works. So here I'll use another type of object, which is the SQL or the service binding. So here to create that, I need to specify the kind service binding. Then I need to specify the name of the instance that I want to bind to, and that is actually my SQL binding, which is the service that I have created earlier, my service instance. Okay, and then I want to deploy this into the OSBA namespace, and I want to the instance reference to reference my SQL instance. Okay, the one that I have created right here, actually, not this one. This is my SQL binding, the name of this service binding. Sorry for that. Secret name. So because this will create a secret file in Kubernetes, that file will be called my SQL secret. I'll copy this to use it later. So now let's go to deploy this SQL binding.yaml into Kubernetes so that Service Catalog will take it and will create that binding for us. Here I'm inside that same folder. So again, I'll go to use kubectl create -f. Then I want now to provision this SQL binding.yaml file. I'll do that. Once it's bound here, you can see it's created. Now I can check for those service bindings using svcat get bindings -n. The namespace that I have used is OSBA. So here I can see my SQL binding. The binding was already created. What this means now, if I go to my Kubernetes cluster dashboard, which I have it here open. If I go now to change to the OSBA namespace, let's refresh this to be able to see that new namespace created. So I'll switch to OSBA namespace, and from here we should be able to see that yes, there is some deployments created for the service catalog and for the brokers and so on. But now if I go to the secrets section, here I'll be able to see that I have now my SQL secret file created right here. I can go to it, and from here I see the different credentials that were bound from my Azure SQL database into Kubernetes. So I can see the database name, the encryption, the host URL, the JDBC URL, which contains the full connection string, the password, the port numbers, the tags if you have specified ones, the URI, and the username for that database. So now it's easier for me to consume those credentials from my application. So through from my app, if I want to deploy it into a container, then deploy it into Kubernetes, I can use environment variables to reference those different credentials. Let's see an example of how that works. So here I have created a sample deployment file. This contains service because I want to access my web app from external using load balancer. Then from here, actually for the deployment file, I have specified the image name that I want to use. And here I'll pass the credentials from the secret file into my container as environment variables. So for that, I have here this section for specifying environment variables. So first one is the host. So from here, I'll reference the host key from my SQL secret. This means we will read the value from here. Okay, so I pass this value to my application. And I'll do the same for the port number, the database, the username, and the password. Okay, I'm referencing my secret file. And inside my application, I have added some code to read and create, to read those environment variables to create the full connection strings. So inside my startup.cs class from here, I'll use the configuration get value for host. So I'll read the host from here, and using the same instruction, I'll read the database, port number, username, and password, and then I'll use them to create the connection string, okay, through using concatenation. Great. With this, now I can connect my web app into the created Azure SQL database. Let's now go to deploy this file and see it in action. So to do that, I'll use the command kubectl create-f app deploy SBC. Once now it's deployed, we can check the status kubectl get pods.nosba, or actually just get pods. And here we see it, or it is running, it's ready. Now let's get the public IP address for this service, kubectl get svc-nosba. And here it is, the external IP address for my web app that I have deployed. So now if I go to that address, hit enter, it will connect me to my web app, and from my web app I know if I go to /products, this actually will try to connect to the SQL Azure database. And here we see the connection was made successful because I'm able to see that page. And from here I can go to create a new product. So let's create a new product, call it Xbox, the cost is 300 for example, then click create, and now we can see that data was persisted inside the database. Let's check if that was really the case. So here I can do that. If I go back to the Azure portal, I have here inside the database, the SQL database, I can go to the query editor, and I can use this feature to connect to my database and see what is available from inside that database. So here I need the login and password credentials. So I'll take those from here actually. And the same I'll do for the password. I'll take the password from the secret file. Click OK, and then it will log me as that user. And from here, you can see the different tables available. If I can expand that, I can see the product table was already created, and I can right click, select top 1000 rows, and this now will show me the first, let's say, select, please, run. And yes, now we can see the data available from my database, which is the one that we have entered a few seconds ago, the Xbox with 300 cost. Thank you for watching, and see you next time.